In part 3 of our lesson on sum and difference identities for sine and tangent, we will do applications of the sum and difference identities. In this example, we are given that the cosine of s is 4/5 and s is in quadrant 4. So s is this angle here in quadrant 4, and we know its cosine is 4/5, which means we know that the x value is going to be 4 and the r is going to be 5. Because we're in quadrant 4, our y value is going to be negative, and it's important to mark that right away so you don't forget. Y is going to be negative square root of r squared minus x squared. Or you can think of it as the hypotenuse squared, so 5 squared, minus the other leg squared, 4 squared. We get the opposite of radical 25 minus 16, which equals the opposite of radical 9, which is negative 3. So we mark that on our picture. We are also told that the tangent of t is 15/8 and that t is in quadrant 3. So we get angle t going here. Here's the angle. Now, because we are in quadrant 3, we know both x and y will have to be negative. The tangent is 15/8, which means the y value has to be negative 15 and the x value has to be negative 8. We can find r by doing the square root of the x value squared plus the y value squared. We get radical 64 plus 225, which is radical 289, which is 17. So r is equal to 17. So now we have the pictures for angle S, and we know all of the sides of the triangle, and we have angle T, and we know all of the sides of the triangle. And now we're ready to find the sine of S plus T, the tangent of S plus T, and the quadrant of S plus T. Sine of S plus T is going to equal the sine of S times the cosine of T plus the cosine of S times the sine of T. One of the suggestions I will make to you, when you're making your letter T's, make sure that you make them look different than your plus signs. Sometimes students will confuse themselves and think it's a T when it's a plus sign, or vice versa. So maybe you want to put a little curly Q on your T, or do something so that your T looks different than a plus sign. Now we're ready to fill in all these values. We know that the sine of S, when we look at our picture, has to be the y value over r, so that's negative 3/5. Cosine of T is going to be the x value over r, so negative 8/17, plus Cosine of s is going to be the x value over r, 4/5, times the sine of t, which is y over r, negative 15 over 17. We have a common denominator already. 5 times 17 is equal to 85. In this first product, we have to do negative 3 times negative 8 is positive 24. In the second product, we have 4 times negative 15 is negative 60, so we're adding negative 60, which is subtracting 60. 24 minus 60 is equal to negative 36, and our denominator is 85. Next, we have to find the tangent of s plus t. Let's write the identity down first. We know it's going to be tangent of s plus tangent of t divided by 1 minus the tangent of s times the tangent of t. And now let's fill in the values. Tangent of s is going to be the y value over the x value, so that is negative 3/4, plus tangent of t is its y value divided by its x value, so that's going to be a positive 15 over 8. In the denominator, we have 1 minus the tangent of s, which we already said is negative 3/4, times the tangent of t, which is 15/8. Now we're ready to simplify this rational expression. So now we have negative 3/4 plus 15 over 8. In the denominator, we have 1 plus 45 over 32. Now at this point, you could add up the numerator separately and add up the denominator separately if you like, or you can clear out all of the denominators in your complex fraction by multiplying by 1 in the form of the LCD over itself. We see we have denominators of 4, 8, and 32, so the LCD would be 32, so that is the form of 1 we want to use to clear out all these extra denominators. Now let's look at the numerator of this complex fraction. We have to distribute that 32 over both of these fractions. So when we take 32 times this first fraction, the 4 will cancel the 32 and become 8. 8 times negative 3 is negative 24. Plus, when we take 32 times this second fraction, the 8 goes into 32 4 times. 4 times 15 is 60. In the denominator, we have to distribute 32 times 1 is 32, plus when we take 32 times this second term, the 32 in the denominator will cancel with the 32 and we're left with 45. Simplifying, negative 24 plus 60 is equal to 36, and 32 plus 45 is equal to 77. The last thing that we were asked to find is the quadrant that s plus t lives in. And we can use the trig values that we've found to help us. We know that the sine of s plus t is negative 36 over 85. So that means the sine of s plus t is a negative number. We just discovered that the tangent of s plus t is positive 36 over 77, so the tangent of s plus t turned out to be positive. If the sine is negative and the tangent is positive, that means that the angle s plus t is in quadrant 3. That's the only place where sine is negative and tangent is positive. In this next example, we're given that the tangent of s is 4/3 and that s is in quadrant 3, and the sine of t is 5/13 with t in quadrant 2. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. Let's start with angle S being in quadrant 3. Here's angle S. Since we're in quadrant 3, we know the x value has to be negative and the y value has to be negative. The tangent is 4/3, which is y over x. We know the y value can't be 4. The y value has to be negative 4. The x value can't be 3. It has to be negative 3. But we know that a negative 4 over a negative 3 would give us that positive 4/3. By now, you might recognize right away that r is going to be 5. But if you don't, you know you could calculate it out. R will be the square root of the x value squared, so negative 3 squared, plus the y value squared, so negative 4 squared, which is the square root of 9 plus 16, which is radical 25, which is 5. And just a quick reminder, r is always positive. Next, we're told that t is in quadrant 2, and that its sine is 5/13, so we know the y value has to be 5, r has to be 13, and because we are in quadrant 2, the x value has to be negative. To find x, we're going to set it equal to negative radical r squared would be 13 squared minus y squared, which is 5 squared. Or you can think of it as hypotenuse squared minus leg squared. This will be negative square root 169 minus 25, which is negative 144, which is negative 12. So we know our x value is negative 12. So we have angle S with all of its sides, and we have angle T with all of its sides. Now we are being asked to find the sine of S minus T, the tangent of S minus T, and the quadrant of S minus T. So let's start with the difference identity for sine. We know we'll have sine of S minus T has to equal sine of S times cosine T minus cosine S times the sine of T. Let's fill in those values. Sine of S is going to equal its y value divided by r, so we get negative 4/5. Cosine of T will be its x value over r, so negative 12 over 13, minus the cosine of S is the x value over r, so negative 3/5, and the sine of T will be the y value over r, which is 5 over 13. Each of these products has the same denominator, so 5 times 13 is going to equal 65. When we multiply the numerators of the first product, negative 4 times negative 12 will be positive 48. In the second product, we have negative 3 times 5, which is negative 15, and we're subtracting that, so minus a negative becomes plus 15. And 48 plus 15 is equal to 63. Our denominator is 65, so the sine of S minus T is 63 over 65. Next, we can find the tangent of S minus T. So we start by writing down the identity. It's going to be tangent of S minus tangent of T divided by 1 plus tangent of S, tangent of T. And let's fill in these values. The tangent of S is going to be the y value divided by the x value. Negative 4 over negative 3 is positive 4/3, minus the tangent of T is going to be its y value over its x value, so negative 5 over 12. In the denominator, we have 1 plus the tangent of S, which we know is 4/3, times the tangent of T, negative 5/12. Let's simplify this a bit. We have 4/3 plus 5/12, and in the denominator we have 1. We've got plus, but we see we've got a negative here, so this will turn into minus 20 over 36. We can clear out the complex fraction by multiplying by the LCD, which for 3, 12, and 36 is going to be 36 over 36. So we're multiplying by 1 in the form of the LCD over itself. Let's look at the numerator. We have to distribute that 36. When we take 36 times 4/3, the 3 in the denominator will cancel with the 36 to become a 12. 12 times 4 is 48, plus 36 times 5 over 12. The 12 will cancel the 36 to become a 3. 3 times 5 is 15. In the denominator, we have to distribute this 36. 36 times 1 is 36, minus 36 times 20 over 36. The 36's will cancel, and we're left with the 20. In the numerator, we have 48 plus 15, which is 63. In the denominator, we have 36 minus 20, which is 16. So the tangent of s minus t is 63 over 16. We were also asked to find the quadrant of the angle s minus t, so we use our trig values that we just found to accomplish that. The sine of s minus t is 63 over 65, so that means it's positive. So sine of s minus t will be greater than 0. The tangent of s minus t turned out to be 63 over 16, which is also positive. So the tangent of s minus t is also greater than 0. When you combine those two facts, if the sine has to be positive and the tangent has to be positive, then the angle, which is s minus t, is in quadrant 1.